Hello, everyone, and welcome to this Nordic Tech webinar. Today's topic is Connect Anything, Intro to Nordic's Bluetooth LE offering. My name is Robin M. Soltnes. I'm a product marketing engineer here with Nordic Semiconductor, and I'll be doing this presentation for you today. So today's webinar is about Connect Anything, Intro to Nordic's Bluetooth LE offering. So what I think that entails is something like this. I'll start with talking a little bit about who is Nordic Semiconductor. Then I'll give a overview over our products. I'll talk some about the hardware tools we've developed to develop with our products, along with the NRF Connect software development kit. I'll also talk about the software tools and the DevZone. And at the end, we will have 15 minutes of Q&A. So this is Nordic Semiconductor at a glance. We are a fabless semiconductor company. We have been doing this since 1983 and pretty much doing Bluetooth Low Energy since the birth of Bluetooth Low Energy. We are a specialist in low power wireless connectivity and embedded processing. So we do everything low power wireless, both the radio and the processors in one package called an SoC. We have been the market leader in this segment for quite a while with our Bluetooth Low Energy and multi-protocol solutions, and we've also entered the cellular IoT business in the recent years, and we're also expanding into Wi-Fi with our purchase of Imagination Technologies Wi-Fi department previous year. So what do we make? We mainly have these two product ranges for now. We have the Bluetooth LE and multi-protocol SoCs, and we have the cellular SiPs. I've given myself the permission to make the cellular part a little bit dimmer because that's not what this webinar is about. You will have to watch Martin Lesson's webinar next week if you want to hear more about that. But both these product ranges consists of integrated circuits, embedded software, and development tools. So all our ICs are optimized for long battery lifetime. We have really much experience in optimizing for battery life and optimizing for low power. We have a really broad IC platform that covers pretty much the entire IoT space. I'd be hard pressed to find a use case for SoCs, integrated Bluetooth SoCs, that isn't spanned by our product range. We also make software for our ICs, and this is mainly to shorten your time to market, because if you were going to start all the way from scratch with bare metal programming, you would spend a lot of unnecessary time just setting up to develop. And here in Nordic, we have done that for you. And we also make development tools, the hardware and software you need to take advantage of the embedded software and the ICs we have made when you're developing. So we try to set the developers in focus. We have excellent tech support, and we have like pretty much the best open forum for developers in the Nordic DevZone forum. So our products in the Bluetooth Low Energy segment, that includes multi-protocol. All our Bluetooth Low Energy SoCs are multi-protocol in some way or form. So here you can see the entire range of NRF52 and NRF53 series SoCs. Starting all the way down at the 52805, which is our smallest and least feature-rich SoC, all the way up to the NRF5340, which is our absolute highest end dual-core massive flagship component SoC. So this slide is pretty busy, and I won't go through all the information in it, but this is more to give you a reference point. As you can see, as the number of the name of the SoC rises, so does the features. And you can see that it's not like the smallest one have the least amount of GPIOs or the least amount of protocols. It's more nuanced than that, meaning that the 52805 only supports Bluetooth LE and only has 10 GPIOs, but it's really, really tiny. It's 2.5 by 2.5 millimeters. Going up to the NRF52810, you get the same size if you choose the VLCSP package, but it has more GPIOs. And then if you look at the 52820, you can see that this have only half the GPIOs, little more than half the GPIOs of the two previous to it. And this is because it has more protocol support and it has the better or a higher temperature rating, which is necessary for use in industrial lighting applications. And then you can just look at the GPIOs and the feature sets to see to the more high ends. They go up, they include all protocols that we support, mesh thread and Zigbee and NFC, and the 5340 has that expanded temperature range and 48 GPIOs. But this is not the whole story. So I've tried to put this into a context of processing power, because what you want is processing power. In addition to Nordics' great radio communications, you also want to select a chip with a processing power that supports your need. So in this graph, you can see that you have flash memory / RAM on the x-axis, and this a little bit arbitrary performance / features y-axis. And as you can see, all the NRF52 series processor uses the ARM Cortex-M4 processor. It's clocked at 64 megahertz for all of them. And you can see the NRF5340 uses two ARM Cortex-M33 processor, where the main application core is clocked at 128 megahertz, and the network processor is clocked at 64 megahertz. This enables the 5340 to have super high efficiency for the network core while being super powerful in processing power at the application core, which is best of both worlds. You have no trade-off with this. And as you can see, there are three variants that have the same flash and RAM sizes at the bottom. They differ from each other in features and protocol support. So the 52805 only supports Bluetooth LE, only has 10 GPIOs, while the NRF52811 has Thread and 32 GPIOs. And as you can see on the previous slide, 52810 has 32 GPIOs but no Thread support. So it's quite easy to distinguish those three from each other, even though they have the same processing capabilities. Then you come to the 52820, the 52832, and the 52833 that's stacked on top of each other in the middle there. As you can see, the 52832 comes in two flash memory and RAM sizes, but with the same performance and features in the y-axis. As you can see, also the 52820 is at the bottom here. That is because it only has 10 GPIOs, but it has a broader protocol support than the 5832, and more like the 5833, which is much higher up. I think that I would maybe, if I were to make this graph again, I would put the 52820 and the 52832 more side by side and on top of each other. But one of them had to be at the bottom for this graph, so the 52820 got the short end of the stick. And then you have the absolute flagships in each series. is the 52840, which is massive, 10,024 kilobytes flash and 256 kilobytes of RAM. Comes in 3 packages. As you can see, all of the SoCs have all package options listed underneath. And then you have the 5340, which is just with its huge 512 kilobytes RAM size and the additional network processor, which just makes it beast at processing. So now you know which processors have the most GPIOs and the least GPIOs, and which has the most highest and lowest flash memory and RAM sizes. But this doesn't tell you the whole story, and it doesn't tell you what chip you need for your project, and we'll come back to that later. But we also have some complementary devices that you may want to use together with your, or which you would if you want to use together with your application. It is the NPM 1100 PMIC that we launched this year, and the NRF 21540 RFM that we launched last year. So the NPM 1100 PMIC is an ultra small power management IC. It has a battery charger specifically developed for small batteries, for instance, in wearables. It is super efficient at regulating voltage, up to 92% efficiency on the voltage regulator. And it's also USB compliant, so you can, when you connect it to a USB source for charging, it will automatically detect what kind of USB port it is and set the correct current limits. It also is just 2.1 by 2.1 millimeters, so you can fit it pretty much anywhere. And then you have the NRF 21540 RFM, which is basically a power amplifier and low noise amplifier for transmitting and receiving signals. It's when used in combination with a Nordic Semiconductor 52 series SoC, you can have up to 16 times range increase in transmission, and it has that gives you a good boost to your link robustness as well. So these are two essential complementary devices when using Nordic Semiconductor SoCs. But as I said previously, this isn't the whole image. Because when you're developing a wireless product, the first thing maybe you want to decide on is what protocol are you going to run off on. And one of my colleagues made this handy diagram to show exactly what protocols are supported on what SoCs. So as you can see, the NRF 52805 and the NRF 52810 is only enclosed by one box, and that box says Bluetooth Low Energy, proprietary 2.4 gigahertz, and ANT. So those are the protocols that are supported by these two SoCs. So if that's the only protocol you plan to use, and if you can do with the processing power that these two and the feature sets that these two SoCs gives you in regards to other features, then you're fine. If you need thread as well, then you can go up to the NR 52811. It has thread and it has 802.15.4. That's the only extra box that this encloses this SoC. And then you can go up to, if you want to add Zigbee to the mix, then you have the 52820. This also has Bluetooth mesh. You can see it's inside all 4 of those boxes. And then you have the NRF 52832, which doesn't have thread 802.15.4 or Zigbee, but it has mesh and it also has NFC. And the same with NRF 52833, also has mesh and NFC and thread and Zigbee. And the 52840 also as well has all of the protocols that we have mentioned now. I thought this was a really informative graphic. So I tried to make my own for the NRF 53 series, and it looks like this. Because the NRF 53 series consists of only the NRF 5340 SoC, it doesn't need any more SoCs than that. This is the best one. supports all the protocols that I have mentioned so far. I've also thrown Matter into there. Matter isn't really a protocol, but I think it's worth mentioning that this SoC, as well as some of the 52 series SoCs, will support developing products for the new Matter standard. But to develop products, protocol isn't all the features you need. Some of our SoCs support some pretty advanced features. One of the advanced features that is supported on a lot of our SoCs is the direction finding, meaning that you can find out a way which way your device is pointing using only the Bluetooth signal. You will need a antenna array as opposed to just one antenna, and it, depending on if you're using angle of arrival or angle of departure, this antenna array will have to be located either at the receiving end or on the transmitting end. So here's an illustration over how angle of arrival works. The transmitter sends a signal which is picked up by 4 different antennas, and the time difference between when the different antennas picked up the signal will make the basis for how to calculate the direction that the transmitting device is pointing. This feature is available on the NR52811, the NR52820, the NR52833, and the NR52840. And also, we are very concerned with security. So on our flagship devices, we have incorporated ARM crypto cell. This takes security to the next level. It accelerates a strong cipher and encryption standards required to the most security-conscious IoT products. The NRF52840 incorporates CryptoCell 310, and the NRF5340 incorporates CryptoCell 312. So this will give you really good control over the security level of your devices when you're developing on them. And we also support LE audio. And LE audio is a part of the Bluetooth 5.2 standard. And the reason I am highlighting the 5340 SoC here, because the Bluetooth 5.2 is supported on all our SoCs, but this is because the NR5340 has a dedicated audio PLL. So this is the device I would want to use if I were developing something that used any form of audio. LE audio is maybe known to some of you or most of you, but it has some very, very revolutionizing use cases for wireless audio transmission, in my opinion. One of them is audio broadcast, so it can be used to do public address instead of using loudspeakers. You can just broadcast it directly to all audio heads, all audio LE, Bluetooth LE audio headsets nearby. The Bluetooth LE standard offers quality improvements over the old classic Bluetooth codec with its new LC3 codec, the low complexity codec, where the old classic uses the SBC codec. This gives you the ability to have a higher quality at a lower transmission rate, which is beneficial both for the perceived quality and also for the power usage. And the power usage gives you the ability to adhere to hearing aids' strict power requirements. So this will be the first mainstream and open standard for making wireless hearing aids. To take advantage of our SoCs, you will need some hardware to develop on. And here in Nordic, we made this easy for you. because we've developed the development hardware, so you don't have to. We have made dev kits for pretty much all the SoCs we've given out. We're starting with the nRF52DK. The nRF52DK, along with all our DKs, contains a Sigurd J-Link programmer and debugger. So you don't need any separate debugger to actually program on it. It contains pin outs for headers for all the pins on the SoC that's on the board. It contains buttons and LEDs, so you can have an EC interface for testing out applications, and you can connect to Bluetooth, and it has an integrated antenna and a lot of nice features for you to be able to actually develop something directly on the DK and test it out. So the nRF52DK utilizes the nRF52832 SoC. So it's obviously made to develop with this SoC, but you can also use it to emulate the nRF52805 or the nRF52810 SoCs on this board. So it's a 3-in-1 development board. When you're developing for the other SoCs than the one that's on the board, you will just have to remember that you have to adhere to the limitation that those two SoCs imposes on you. For instance, the nRF52805 that only has 10 GPIOs. You can't use more GPIOs if you plan to use the 805 in your final project. Then you have the nRF52833DK. As the name implies, it uses the nRF52833 SoC. Can obviously be used to develop for this SoC on this board. And you can also emulate the nRF52811 and the nRF52820. Then moving up to the nRF52840DK, what SoC is on it is pretty obvious by now. This is the first DK that has an external flash memory on board. Because even though the nRF52840 was our flagship SoC at that time and had a massive 1024 kilobytes of flash memory, we could imagine people needing more. So we smacked the external flash memory on there, and if you don't want to use it, you don't have to use it, but if you use it, keep in mind that you will probably need some external flash memory on your final product if you if you can't adhere to the limitation that is on the SoC itself, even though it has a pretty good flash size. Same with the nRF53340DK. This is the DK for our flagship nRF53340 SoC. Our dual core with its 128 megahertz processor application core and the 64 megahertz networking core, which means that the networking doesn't steal any processing power from the application, and you can run really big applications on this SoC. And because you can run this big applications on this SoC, we could also imagine that you want more flash memory, and that's why we smacked the external flash memory onto there too. We also make some other development hardware. Even this is the main development hardware that you absolutely need to develop on our SoCs. We have some nice to haves. We have the Power Profiler Kit 2. It comes with a graphical user interface, unlike the Power Profiler Kit 1 for those, or the original Power Profiler Kit for those who are familiar with that one. This is a completely standalone device, so you just hook it up to your PC with a USB cable, and then it functions independently of any dev kit. It can be used as an ampermeter and a power source at once, and it also has digital inputs that you can connect to GPIOs on your dev kit, and you can see the power consumption of the device you are measuring, as well as the state of those GPIOs on a timeline, which gives you a really good idea of what's consuming power on your application. This has been very popular among the developers using Nordic Semiconductor hardware. Then we have the Thingy 52, which is like a more of a app developers development kit. It comes with a battery. It's a battery powered device. It has an integrated battery. It has integrated sensors, temperature, humidity sensors, and also accelerometer and gyro. And it also has a button and an LED and a microphone and a buzzer, all already uh, integrated into the device. It also comes with its own custom firmware, and this is what makes it great for app developers who doesn't want to deal with the firmware or the circuit integration that usually is connected with developing embedded systems. So the firmware is designed to broadcast services for all the integrated hardware parts. So if an app developer wants to use, for instance, say the buzzer, it just connects to the buzzer service wirelessly through the app that you're developing. And you can send messages to the buzzer and have the buzzer react to them without having to do any embedded development yourself. So this is a really great hardware tool for that kind of developer. And we also have the nRF52840 dongle, which uses an nRF52840 SoC. It has an antenna and it has some GPIO solder pads connectivity and a built-in USB connection. And this is for connectivity. You can use it as a standard multi-protocol Bluetooth dongle. So if you have a PC and you want to connect to, for instance, a Thread network or a Zigbee device, you can use this instead of buying some third-party module. This can also be programmed as a dev kit, but then you will need a dedicated J-Link programmer, Sega J-Link programmer, or another dev kit, because this doesn't have an onboard programmer like the dev kits does. But the main use case that we imagined for this is for connectivity purposes. So to take advantage of all this development hardware and or SoCs, you will need some development software. And that's why we have made the NRF Connect SDK. It is our software development kit. So it's not a software in itself, although it contains some software. This is a highly integrated software development kit that contains samples and applications that are ready to be compiled and then just downloaded and run on your device, either it be a dev kit or a custom development board. So the thing about our samples and applications is that they come free of charge, and you're also allowed to modify them and even use our samples in your finished product. There's no licensing involved with using our samples and applications in the NRF Connect SDK. It also comes with middleware to allow you to connect different parts of your software together. It integrates the Zephyr RTOS, so you have the advantage of an RTOS scheduler. It also makes porting code much easier, and it also has predefined libraries for a lot of stuff that you want to do on the development side, and hardware drivers for a lot of different hardware that you could like to integrate into your final application. It is a scalable and unified SDK both for the nRF52 and nRF53 series. Previously, we had the nRF5 SDK that only supported the nRF52 series of current SoCs. The nRF5 SDK is not longer recommended for new designs. We still support it, but if you're starting a new design with an nRF52 series SoCs today, we recommend you to start with NRF Connect SDK. This is where we will post all our future updates and feature improvements. And for the nRF53 series, only NRF Connect SDK is supported. So with this SDK, we have one single code base for all our devices, meaning that when you start a new project and you may have some new hardware, the code base is still the same, which I think is a big advantage. Also, if we have the Zephyr RTOS that I already mentioned, with all the advantages of using RTOS in embedded development. You don't have to use the Zephyr RTOS. You can still do bare metal programming, but this is integrated in this NRF SDK right from the get-go, even though. We now support production on all nRF52 and 53 series devices in the NRF Connect SDK, so you can both do development and production on it. And last but not least, it installs via the toolchain manager in our NRF Connect SDK, or in the NRF Connect desktop app, which I will talk about a little bit more later, which means you don't need to download a lot of different repos from GitHub. It's pretty much a one-click operation to install the NRF Connect SDK with the NRF Connect desktop app. So that brings us over to the NRF Connect desktop app, which is what I call a software tool. So this is how the NRF Connect for desktop app looks like. It contains a lot of different apps that is also useful when which is useful when you're developing on the NRF Connect platform. So the first app I want to talk about is the toolchain manager. This is what I talked about that allows you to install the NRF Connect SDK onto your computer and with one click. And with a recent update, you're now also allowed to install a expansion to your VS Code IDE. So you can have the NRF Connect SDK installed directly into your VS Code IDE and open VS Code from the toolchain manager after you have installed the NRF Connect SDK. We also have support for the Sega Embedded Studio, which we have been using previously for a long time, and this also can be installed and opened through the toolchain manager. Both of these IDEs can be opened separately, like you would normally open the desktop app on your computer, but you don't have to open it through the toolchain manager to use the NRF Connect SDK when it's first installed. Another advantage of the toolchain manager is that when there's a new version of NRF Connect SDK released, you will get it in this list and you can just install it with one click and also have it integrate directly with VS Code and Sega Embedded Studio. You are allowed to use any IDE that you want with the NRF Connect SDK, but these two options are the one that's easiest for you to install with the toolchain manager. If you're using any other IDEs, I know there's a lot of fans of other solutions than VS Code, which is my preferred solution. Then you have a little bit more hassle of installing the NRF Connect SDK into it, but when you get it up and running, you should be able to, or you will be able to use whatever IDE you prefer. If you go to back to the NRF Connect desktop app, we can open the programmer app. The programmer app looks like this. It is mainly used for programming a precompiled hex files onto a dev board or a SoC. So it has two file memory layouts you can see. The one is will show you what is on the SoC that's connected to the PC via a dev kit or a pin board, I guess. And it shows you where in where in the memory of the SoC, different parts of the code are stored. And it also allows you to add a hex file to the program and show you how this will look when it's flashed to the SoC. You can also use this to erase your SoC's memory and erase and write and do different operations that uses the programmer on the SoC directly, which is a really nice feature to have in this app. And then we have the Power Profiler app. It looks like this. Here you can see I have a application that uses power in a square waveform, meaning it uses little power, then it uses much power in some seconds for each. It looks like it's 1 second each. And you can see also the 1 and 2 and 0, 1 and 2 are the digital inputs that I told you about. These are all high here, but if they were connected to GPIOs that switched states, you can see it on the side. It's on the same timeline as the power consumption. The resolution of the Power Profile Kit 2 is 10,000 samples per second, so it should be accurate enough for most applications to power profile your code. And then there's also Bluetooth LE app, which shows you connected Bluetooth devices and allows you to write values to services and a couple of other features that I will come back to when I talk about the mobile apps, because the Bluetooth Low Energy app is much like the NRF Connect for Mobile app. And all our mobile apps are available on Android and iOS. We have a variety of them. The complements are examples in the SDK. For instance, the NRF toolbox can be used with a lot of different samples. It contains the user interface for the samples that require that. So if the sample requires that you press a button on a connected device, you can probably find this button in the NRF Toolbox app. It also has DFU capabilities in this app and MCU manager, and also the UART receiver transmitter. So if you're transmitting UART over Bluetooth, you can see what's transmitted on the UART right on your mobile device. Then we have the NRF Connect app, which I already told you is much like the Bluetooth LE desktop app, but for mobile. So it contains the Bluetooth scanner, which allows you to see and connect to devices within range and see the services they broadcast and write to them directly to the app. And it also contains an RSSI viewer and a peripheral provisioning tool. So you have a lot of nice features in this app. Then you have the NRF Mesh app, which is used for provisioning and commissioning mesh nodes if you're setting up a mesh network based on our mesh samples. And we have more apps like the NRF Blink app, which is basically just a button to make a LED flash on and off on a dev kit. All or source code for most of our apps are available on the Nordic GitHub. The only app I've listed here that isn't available is the NRF Connect for Mobile source code, because that's our trade secret. So then we only have the DevZone left, but this isn't only, because DevZone is a thing Nordic should be really proud of. I think I've deleted one of my slides. I'll try to find it. There we are. The DevZone is our a community of developers. So we use this for tech support, and all that has received tech support from Nordic Semiconductor have probably been to DevZone. But this isn't the only thing we do. We also have a community of over 80,000 developers with over 4.4 million annual site visits. Here you can both get in touch with our technical support team but you can also use it as a forum to meet other developers and brag about what you achieved with our hardware. And you can also ask questions that is more not so tech support related, but maybe you want to have some input or discussions around topics that are related to it, not necessarily to one problem, but have a community support. Then you have the Nordic Semiconductor tech support team there. We have probably one of the best tech support teams in this market. Full-time employees, or a lot of full-time employees that works hard to give everyone the best possible tech support you could possibly imagine. And they also make tutorials and build logs and blogs that complements all the direct one-to-one customer tech support they do. Then we have Nordic Tech webinars, which of one you're watching now, and we also release blogs on the Get Connected blog, which is less technical and more high-level oriented. And we released the Wireless Quarter magazine, so you can read what's shaking and moving in the Bluetooth LE segment once every third month. This comes out both in paper and now it's mostly digital. So to summarize, we have the best in class broad selection of SoCs. We have unique high performance connectivity stacks supporting a lot of different protocols. We have the comprehensive NRF Connect SDK and extensive software and hardware development tools, which in combination lets you develop the perfect application. And we have the best developer community and tech support team in the business. And all of this adds up to you making a fantastic product with our hardware. Sign up for more webinars at www.nordicsemi.com/webinars. I think webinars.nordicsemi.com is simpler to remember, but that's just me. Thank you so much for watching this Nordic Tech webinar, and have a great day.